Assalamu alaikum wa rahmatullahi wa barakatuh. You are welcome back from the Eid al-Kabir break. May Allah accept it as an act of ibadah. Once again, I welcome you back to another edition of our online class. If you remember, before we go for the Salah break, we talked about oxidation and reduction, where we define oxidation and reduction in terms of electron transfer, in terms of oxidation number, in terms of hydrogen and oxygen. We also define it in terms of electronegative and electropositive elements. Today, we are going to be looking at oxidizing and reducing agents. Because in a redox reaction, that is in an oxidation-reduction reaction, there used to be oxidizing agents and reducing agents. So that is what we are going to look at today, oxidizing agents. Oxidizing agents, they are substances that gain electron, and in the process they get reduced, and also their oxidation number decreases. Now, features of oxidizing agents. One of the features of oxidizing agents is that they are electron acceptors. In a redox reaction, they are the ones that accept electron. They supply oxygen to another substance. There are also substances that supply electronegative element to another substance. That is, they supply, for example, electronegative element is oxygen, and so on like that. Now, there are also, another feature is that there are also substances that whose oxidation number decreases in a redox reaction. So that is that on oxidizing agents. Now let's look at the reducing agents. Reducing agents, they are substances that loses electron, that means they donate electron, and then they get oxidized in the process, and also their oxidation number increases. Now, features of reducing agents, they are electron donor, that means they donate electron. They are substances that remove electronegative element from a substance. There are also substances whose oxidation number increases. Now, if you look at this definition and their characteristics, you know that oxidizing agents are opposite of reducing agents, and both are present in oxidation-reduction reaction. Now, from this our explanation, let's look at some examples. If you look at example 1, if you look at from hydrogen sulfide down to sulfur, I said it's oxidation, because sulfur there in -2 state give out 2 electrons. It gives out 2 electrons and it becomes oxidized from -2 in the hydrogen sulfide to 0 oxidation state. So hydrogen sulfide there donates 2 electrons to sulfur 4 oxide. On the other hand, sulfur 4 oxide accepts the electron and become reduced. Now, the second example, if you look at the second example here, I said from copper 2 oxide to copper is reduction. It's reduction being that copper is an oxidizing, copper 2 oxide is an oxidizing agent, and hydrogen is a reducing agent. So copper accepts 2 electrons, and then it becomes reduced from copper 2 to copper 0. And then if you look at hydrogen here, also oxidation from 0 to that, as you have seen it there, is oxidation. Now let's go back to example 1. Hydrogen sulfide here is a reducing agent, while sulfur 4 oxide is an oxidizing agent. So that is that on that example there. Now let's go to the third example. The third example, if you see here, I said from hydrochloric acid down to water is reduction, and then from manganese 4 oxide to manganese 2 chloride is oxidation. Now, if you look at hydrogen chloride there, is acting as a reducing agent. By what? By donating electron to the manganese 4 oxide, and then itself it is being oxidized. While on the other hand, manganese 4, which is an oxidizing agent, accepts the electron, and then it becomes reduced from manganese 4 to manganese 2. So hydrogen chloride there is behaving as a reducing agent, while manganese 4 is behaving as what? As an oxidizing agent. So that is that. Now let's look at the common examples of the common oxidizing and reducing agents. As we have seen there, oxygen, sulfur, manganese 4 oxide, chlorine, peroxide, concentrated H2SO4, and so on there, they are all examples of oxidizing agents. Now, reducing agents. Reducing agents, as we have seen here, we have hydrogen, we have hydrogen sulfide, carbon monoxide, ammonia, carbon, sulfur 4 oxide, iron 2 salts, then metal higher up in the electrochemical series. They are all reducing agents. They are all reducing agents. Now, as we all know, generally metals are reducing agents, while non-metals are oxidizing agents. Reason because metals donate electron, while non-metals accept electron. Now, let's look at the test for oxidizing agents. Number 1, I said reaction of oxidizing agents with hydrogen sulfide. This time around, hydrogen sulfide will be behaving as a what? As a reducing agent. And when you bubble hydrogen sulfide into a solution of oxidizing agent, into a solution of oxidizing agent, into a solution of oxidizing agent, a yellow precipitate of sulfur is formed there. If you look at the reaction there, when you look at the reaction there, you will see that potassium dichromate 6, which is an oxidizing agent, when it reacts with hydrogen sulfide, that means acidified potassium heptazochromate 6. Potassium heptazochromate 6. When acidified potassium heptazochromate 6, when hydrogen sulfide is bubbled into a solution of acidified potassium heptazodichromate 6, then the color of the potassium, which is orange in color, will change to green, because the heptazodichromate 6, which is green in color, now accepts electron to become dichromate 3, and that is why the color will change from orange to green. And on the other hand, sulfur in hydrogen sulfide is being what? Is being oxidized to from -2 to 0. So that is that. And sorry, there is an arrow here. You see it clearly in your notes. Now, the second one is the reaction between iron 2 chloride. That is reaction of iron 2 chloride with oxidizing agent. Normally, when iron 2 chloride reacts with oxidizing agent, iron 2 chloride being a reducing agent now, we give out an electron to become oxidized to iron 3, and that is why the color will change from green to brown. The color will change from green iron 2 to brown iron 3. Now let's look at the third one, which is reaction of oxidizing agent with potassium iodide. Now what happened there is that when they react, the iodine is going to be liberated. Iodine is going to be liberated, which is what? Which is brown in color. And when this iodine, when it's added to starch, it becomes blue-black. That means test for starch. This is what happened there. If you look at this, manganese, which is manganese 7, which is oxidizing agent, when it reacts with iodide ion, then the manganese, the iodide ion, now we give out electrons to the oxidizing agent, which is the manganese 7, and then manganese 7 will be reduced from manganese 7 to manganese 2, and then ion will be oxidized from minus to 0, which is oxidation. There, that is what happened in that reaction. Now, in each of the cases there, the reducing agents normally give out electron, while the oxidizing agents accept electron. Now, let's look at the last one, which is the test for reducing agents. As we have seen in the reaction, the first reaction there is reaction with iron 3. When reducing agent reacts with iron 3 salt, what happens is that the reducing agent turns brown iron 3 to green. That means iron 3 is being reduced from iron 3 to iron 2. From iron 2 because it has accepted electron. So the color is going to change from brown to green iron 2. As we have seen it here, here is a reducing agent, which is hydrogen sulfide reacting with iron 3, which is now an oxidizing agent. The reducing agent will donate electron to iron 3, and then iron 3 gets reduced from iron 3, brown in color, to iron 2, which is green in color. On the other hand, the sulfur in hydrogen sulfide will be oxidized from -2 to 0. The second reaction, that means reaction of reducing agent with acidified potassium permanganate. You see there, we have where hydrogen sulfide gas is bubbled into acidified potassium permanganate. The same thing happens. The manganese, the manganate ion accepts electron from the hydrogen sulfide, and then it becomes reduced from manganese 7 to manganese 2, where the hydrogen sulfide is oxidized from -2 to 0 there. So the last one, which is reaction with acidified potassium heptaoxodichromate 6. There, the same thing happened. Let's go back to that reaction in oxidizing agent. Is still the same thing. If you look at the reaction here, it's still the same thing here. So the hydrogen sulfide still donates electron. The heptaoxodichromate 6 accepts the electron and become reduced to dichromate 3. That means from orange to green in color, and then the hydrogen sulfide become oxidized. So you can see there where I wrote the color changes from orange to green by reducing the heptaozo dichromate 6 from +6 to chromate 3 from +6 to +3. So that is that, and that is where we are going to stop for today's class. So in the next time we'll be looking at how to balance a redox reaction. Assalamu alaikum wa rahmatullahi.